Hey guys, today I'm going to teach you all about square roots and cube roots. You should already know how to find the square and square root of a number, but by the end of this lesson, you'll be able to find cube roots of numbers and recognize that that's just the inverse of numbers cubed, or with an exponent of 3. So go ahead and get out your binder, turn to the math section, and get ready to take some notes. So this first part is all stuff that we should already know. This first section is all about squaring numbers. Remember, squaring a number is raising that number to a power of 2. We saw squares whenever we were talking about 5 squared is the same thing as 5 times 5. This is also the same thing as 25. So we know that squaring a number means putting it with an exponent of 2. So let's review. The next part just says when a negative value is squared, just be careful to know whether the negative sign is inside or outside the parentheses. For example, on this problem, negative 2 is in parentheses. This is the same thing as negative 2 times negative 2. That's the same thing as positive 4 because a negative times a negative is positive. However, if you look next to it at negative 2 squared, there is no parentheses, and that exponent is only attached to the 2. That negative is not in parentheses, so this is 2 squared, and then you put a negative in front of it. So 2 squared is 4, and then you'd have to just bring that negative in. So go ahead and just try these next ones by yourself. This should already be in your binder, so this should be reviewed. Press play when you're ready to check. Okay, so you should have gotten this. I have negative 3 times negative 3 is 9, and then this one does not have a parenthesis, so it's just negative 9. So the same thing here with negative 4 squared without the parentheses. It's a negative. With the parentheses, it's a positive. So that should be review. Let's look at the next part of this. Again, more review. Squaring a number is the inverse of taking the square root. So remember, the square root symbol looks like this. If I know that 4 squared is 16, I know that the square root of 16 is 4. They're opposite operations. That's what inverse means. It's like the opposite of add is subtract, and the inverse of multiply is divide. The inverse of squaring is taking the square root. So we do want to remind ourselves that technically we have two solutions that come out of this, because like we see here, negative 4 times negative 4 is also 16. So the square root of 16 can be 4 or negative 4, because 4 squared is 16 and negative 4 squared is also 16. Okay, I wrote that kind of better. So the next thing is we reminded ourselves that the positive square root is known as the principal square root. So just in general, we accept that the square root of 16 is 4. That's usually what we'll go with. That's what your calculator will say. But we do know that in reality, there are two possible solutions. It could be negative 4 or positive 4, but we're going to just accept the 4 for now. And that's what this last line says. When using the square root sign, the solution is the positive square root. So let's go ahead and get into this new stuff. So cubing a number is the same thing as raising a number to a power of 3. So I would say that, like, if I had a base 2 with an exponent of 3, this is the same thing as 2 cubed. Remember, anything to the power of 3, I could say 2 cubed, and that just means 2 times 2 times 2. So just like up here where there's an inverse of 4 squared, and that would be the square root, there is an inverse of 2 cubed, or a number cubed, and that is called the cube root. If we take the cube root of a number, we write it the same way that we wrote our square root. So practice doing that on your paper. I put a little, it's like a hook on a division sign. The only difference is that right here between this little hook part, there wasn't anything before. Now there's going to be a little 3. So a little 3 there means that I'm trying to figure out what number times itself 3 times gets me the number that's inside of that cube root sign. So for example, this is how a cube root of 8 would look like. The cube root of 8 is 2, because 2 times 2 times 2 equals 8. So this cube root sign just means what number times itself 3 times to get you this. So let's try 3 practice problems. Go ahead and pause the video and try all 3 of these. You're finding the cube root of each number. So go ahead and pause the video and press play whenever you're ready to check. Okay, so when I'm looking at a cube root, I'm trying to figure out what number times itself 3 times to give me this number on the inside. So one strategy that I use whenever I'm finding the cube root of a number is to make a factor tree. So what I do is I always write the number and then I branch off 2 multiples of that number. For example, I know that 9 times 3 is 27. When I get a prime number from the factor tree, a number that's only multiples are 1 and itself, I circle it. 3 is a prime number because only 3 and 1 go into 3. I can't write any more multiples from it. So it's called a factor tree because it has branches that branch off. So I do the same thing for 9. 3 times 3 is 9. So I know that 3 is a prime number and I can circle it. Since I have a 3 times a 3 times a 3, I know that their product would be 27. So I can multiply this times this times this to give me 27. And since it's the same number 3 times, I can write that as 3 cubed, which means that 3 is the cube root of 27. So again, you might have known that off the top of your head, but this is a strategy in case you don't know. Like number 2, you should just know 1 times 1 times 1 is 1. So the cube root of 1 is also 1. But maybe you don't know what the cube root of 125 is. So I'll go back to that factor tree. This is always a strategy that you can use. I'm just listing the factors of 25. So I'm just thinking what times what gives me 25? What two numbers multiply to give me 125? So I know that 25 and 5 multiply to give me 125. I know that 5 is a prime number because only 5 and 1 go into it. So I can move on to this other 25 and see if there's any factors I can draw from that. I know 5 times 5 is 25. So then I circle the 5 and the 5. This is as simple as they can get. 5 times 5 times 5 means that I could write this as 5 cubed, and that would equal 125. So the cube root of 125 is 5. So the check-in question for you is, can a cube root ever have a negative solution? Why or why not? Go ahead and think about that by yourself. Try something and then press play and ready to check it. Okay, so by now you should have thought about this. I'll go ahead and give you a number example. So let's say, can the cube root of 8 be a negative 2? That would mean negative 2 times negative 2 times negative 2 would have to equal 8. Well, let's try that out. So negative 2 times negative 2 is positive 4. A negative times a negative is always positive. Then I bring down this other negative 2. Now I have a positive 4 times a negative 2. So a positive times a negative is always a negative. So 4 times 2 is 8. If I have a negative answer for a cube root, I know I've done something wrong because a negative number multiplied by itself 3 times will always have a negative outcome. So this is just what I said written out. Can a cube root ever have a negative solution? No. A negative number times by itself 3 times will always have a negative solution. Go ahead and take a second to fill out this quick table. This is a really good reference table for you to use for the first 10 perfect squares and now perfect cubes. Go ahead and take a second, fill out this table by yourself, and then I'll go through and fill it out, and you can press play and ready to check. So here are my first 10 perfect squares, and here are my first 10 perfect cubes. So that means I multiplied this number, the base, by itself 3 times to get this number. Please don't forget, this is not 8 times 3. This is 8 times 8 times 8. All these numbers multiplied by themselves 3 times, not that number times 3. Okay, so let's look at some example problems. So I have 6 problems right here for us to practice together. I'll go ahead and go through them, but you can feel free to pause, try them by yourself, and then press play and ready to check. So I have a negative 4 squared, or negative 4 times negative 4. I know that a negative times a negative is always positive, and 4 times 4 is 16. So the correct answer would be 16. That's it. For the next problem, I have a fraction. So this is 2/5 times 2/5. Basically, you can write it two ways. This is like 2 squared over 5 squared. You can also think about this as 2/5 times 2/5. Either way, you'll end up with the answer 4 over 25. So whichever way you want to think about it is right. Let's look at number 3. You have a negative 6 squared. So remember, if the negative is on the outside and there's no parentheses, if you type this in the calculator, it will recognize this as 6 squared first. So 6 times 6 is 36, and then it'll just put that negative sign on the outside. So since there's no parentheses, it's a negative 36. Number 4 says take the negative square root of 144. So I know the square root of 144 is 12 because 12 times 12 is 144. And then there's a minus on the outside, or a negative, so I have to put that negative on the outside. Number 5 is a decimal. So I know that my answer is going to be a decimal. What number times itself gives you 49? I know that's 7. And since there's a decimal, I'll just put a decimal there too. That's it. And then number 6 says what number times itself gives you 4, and what number times itself gives you 9. So I'm really breaking this part into two things. You might want to cover up the bottom, cover up the top, and do it one step at a time. So the square root of 4 is 2, and the square root of 9 is 3. and I can just draw that fraction line in the middle since there was a fraction line here. That's all I'm doing. Now let's take a look at these cubes and cube roots. So go ahead and take a second, pause the video if you need to, and try these by yourself, and then press play when you're ready to check. Okay, so I'm going to go through these with you. So I have -5 3 times. So -5 cubed is the same thing as -5 times -5 times -5. And it sometimes helps to write it all out like that and do it one step at a time. So I know -5 times -5 is 25. Then I bring down that -5. So it's a negative times a positive. So my answer will be negative. And 5 times 25 is 125. So -125 is my final answer. Number 8 says do 1/4 times itself 3 times. So I'm just going to write out that fraction 1/4 times itself 3 times. When I multiply fractions, I multiply straight across on the top. So 1 times 1 times 1 is 1. And then 4 times 4 is 16 times 4 is 64. So multiply straight across on the top and then straight across on the bottom. And this will be your final answer. For this problem, I have no parentheses, and I have a 10 cubed first. So I'll do 10 times 10 times 10. That's 1,000. And since there's a negative on the outside, I have to just bring down that negative. Okay, so for one like number 10, it says take the cube root of 216. So I don't know what times itself 3 times gives me 216. So there's a few strategies. One, I can look at my chart of perfect cubes. So we have that chart we just wrote from the perfect cubes, 1 through 10. You could also do a factor tree. So you could just list your multiples of 216 and start dividing numbers in your calculator until you figure out that this cube root of 216 is just 6. So the chart's probably easiest. So let's look at number 11. It says take the cube root of 512. So I'll look for that little 3. Take the cube root of 512. The cube root of 512 is 8. And then there's a negative on the outside, so it'll be a -8. Then we'll take the cube root of each one of these numbers in the fraction for 1 over 27. The cube root of 1 is 1, and then the cube root of 27 is 3, because 3 times 3 is 9 times 3 is 27. So 1 over 3 would be my final answer. So here's 2 application questions that you'll probably start seeing a lot. Let's go through them like we do any word problem and underline anything important, writing down what we know and then what we need to know. So I'll read it to you. A set of 121 chairs needs to be arranged in a square formation for a school assembly. How many chairs should be lined up in each row? So I'm looking at a square, and I want the same number in each row. These are clues that I need to take the square root of 121. Remember, I'm not dividing by 4 because I'm not taking that 121 chairs and just splitting them into 4 rows. I'm splitting them into that many chairs, the same number of chairs in each row. So you should know that the square root of 121 is 11. And the question was asking how many chairs should be lined up in each row. You should have 11 chairs. You always want to label your units. The next question says the volume of a cube is given below. So it's a cube, and we have the volume. Find the length of one side of the cube. So let's remember what volume means. Volume means length times width times the height. So when you see a question about volume, you should know that you had to multiply 3 numbers by itself. It's a cube, so each one of these is the same. Each one of these is the same length. All of those side lengths are the same. So if I'm given the volume, I need to take the cube root to find out what the length of one side is. So the hint is it's a cube. We know this is called a cube root. And there's a little 3 here that says it's already been cubed. Those are all your hints that tell you need to find the cube root of 729. So you need to figure out what number times itself 3 times gives you 729. That would just be 9. It says it's in inches, so you need to write inches. You don't need to write inches cubed because each side is just 9 inches. When you multiply them all together, that's whenever they become cubed. So each side length is just 9 inches. All right, guys, that's it. If you made it to the end of this video, please put your least favorite food in the comments. Today, we learned all about square roots and cube roots. So now you should be able to find square roots and cube roots and recognize these operations as the inverse of squaring and cubing. Now you should go back to the calendar and complete any other assignments you have left for the day. Let me know if you have any questions. Bye.